Hey guys, this is Terence and welcome to the new episode of an Architect's P5.js notebook. And as you noticed, I switched from processing to P5.js because I feel the processing is a little lack of flexibility. While P5.js, which is a JavaScript-based library, which enables me to deploy my sketches and like other 3D models to multiple platforms, especially on the website. So from this episode on, this series of video will insist on the P5.js library. And yeah, this is which way? Yeah, this way. This is today's sketch. It's a hexagon subdivisions. So let's get started. I want to first pull up the simple diagram to show the whole process of creating this pattern. So the first, we need to create a hexagonal tessellation. That's the basis of all of our sketches, or of these sketches. Sorry. And the second step is to define a subdivision function, or more precisely, it's a recursively subdivision function for the hexagon cells. And we can define the iteration of the subdivisions, like if the iteration is just 0, no subdivision happened. If the iteration is 1, just one subdivision happened. But when the iteration goes up, and the recursive subdivision will happen on each subcell of the hexagon. So the shape will become more complicated and more delicate. And with the help of this subdivision function, we can subdivide all the cells in the hexagon, all the cells of the hexagon tessellations. But we don't want to provide a fixed iteration. Actually, we want the pattern looks varied, so we can randomly define the iteration number of each cells. So so in this condition, each cell will be subdivided in different iteration and with different level of details. And the last step is we can try to rotate all of the cells to make the whole pattern looks very dynamic. So let's start coding. Let's first working on this hexagonal tessellation part. Let me open this processing app, and you can see now it's in P5.js mode. And also I want to start I want to create the sketch screen aside. Then when we made modifications here, I can just refresh this web page and see the real-time results. So first we need to create the canvas. We should say create canvas in P5.js, and the size could be 700 by 700. And I'd like to set the background as black, so that will be quite clear visually. Refresh it, and we have our basic canvas. So the first thing we need to do is to create the tessellation, as I just mentioned. But I find an easy way to create tessellation is first find the corner of each find the corner of each cell, then repeat these corners in each of the center point I prefer to create the center point of this tessellation. Then based on each center point, I will do a rotation to create these 6 points. So here are basically 2 functions. The first function is to create the tessellation, the center point tessellation, while the second function is to, based on these tessellations, to create each corner points. So this is the logic. And what I want to do is first create a function called getCorners, which is to get the corner coordinates of each hexagons. But these corner coordinates are based on the 0, 0 point. It's not on each of the tessellation point, because I want to create a general function that apply to each of the possible points. So to make the whole code very flexible. So for this function, I need this I need I need 4 inputs. The first one is the size of the hexagon. The second one is called corner numbers, which defines the shape of hexagon. If you have if you provided 4 corner number, if you provided the corner number as 4, that will create a square. But if you provided the corner number of 6, you will create a hexagon. So on and so forth. And we need a start angle and also an angle step here. So inside here, we need to first declare an empty corner list called corners. Then we also need to define the radius of the radius of the hexagon. Yeah, I think I need to explain a little bit here, because what we define size is actually if we define a size, that is actually, I think it's easy to draw here. Yeah, if we define a size, that means this distance, but actually the radius starts from here. It is this distance. So there is a difference in length between this line and the half of the size. I mean this line. So to calculate the length of the radius, we need to use the length of this line and divide it by cosine 30. Then, cosine radians 30. Then we can get the length of the radius. Then we can do it here. We can say radius equals to size. First, we divide it into half because we just need this half instead of the whole size. Then we can divide it by cosine radians 30 because I used to use angle instead of radians, so I prefer to convert the angle to radians every time. Then I can read my code easier. And after this step, we should loop over all the corners. We can say for let I equals to 0 when I is smaller than corner number I++. And the next step is we should find the angle of each point. Maybe just for example, if we start from this point down. Now the angle of this point, the angle of these two lines is minus 30 or negative 30. If we rotate to this point, the angle is negative 90. Keep rotating. Here is 90 plus 60 is 150. Just so on and so forth. So we need to find the angle of each point. We need to find the angle of each point comparing to this baseline. So we can say radius. We can say current angle equals to radians start angle and plus I multiply by radians again, angle step. And now we can find the x coordinate and y coordinate of each point. Then we can just say let x equals to radius multiply by cosine current angle, because this value is already a radians. I don't need to convert it to radians again. Let y equals to radius multiply by sine current angle. Yeah. And then push these coordinates, push these two coordinates into the corners, which is corners dot push a list x and y, we want it format as a point instead of single value. So we do it, we push the list instead of just x and y into the corners. And at last, we should return these corners. Yes, we have this. We have a function to create these corners. Now we need another function to create the center point of each polygon, and then convert this to based on this center point to create the hexagons. So the second function we want to define is called function grid. And we also need to pass some parameter into this function. The first one is size, and the second one is angle. This angle means the start angle. I should specify it. Start angle, yeah. And inside here, we first need to find points, as I just mentioned. So we can say let x number equals to an integer width divided by size. This line of code means we should find the number of points along the x-axis based on the width of the canvas and the size of each cell. We will do the same thing on the y-axis, which is height divided by size. Yeah. And with these two numbers, we can start to placing those points. So we need to do a nested loop over y number and x number. So we need to start from the y number. For let y equals to 0, and when y is smaller than y number, yeah, this time I prefer to set it as smaller or equal to y number to fill the gaps at the end, at the two ends of the canvas. Then y plus plus with a curly bracket, and also the second level of loop inside here, we need to loop over the x-axis when x smaller or equals to x number x plus plus. Then we can start find the coordinates of each. We can start to find the coordinates of the center point of each hexagon. We can say we should first find the x coordinate. So we can say coord x equals to x multiplied by size. And I think we can just do this, and I will add some codes later to modify it. Y multiplied by size. And this is problematic because there are two issues here. The first issue is that there is a shift in every other line. There's a shift of center point in every other line. It's quite straightforward if you look at this diagram. The second problem is that, I will draw another line here. Yeah, I hope this makes sense. Yeah. And this is the distance from the previous, this is the y distance from the previous row of hexagon to the current row of hexagon. And you can see these two distances are not exactly equal because this distance is based on this distance is related to the radius, while this distance is just single size, just simply size. So I think we discussed how to convert this distance to the radius, and we might need to do the same thing again. So let's first modify the x shift, the shift on distance, the shift of position on every other row. So here we can keep adding some codes like Yeah, we can shift it. We can just minus this value with size divided by 2 and multiply by y modulo by 2. And for the y shift, for the y distance, we can just multiply this value by cosine radians 30, I think. Yeah. So we have these two coordinates. We have x coordinate and y coordinate. Now we need to compile these two value into the compile these two value as a point. So we can say coord equals to coordinate x and coordinate y. Now the next step is based on this central point. We need to create the hexagon corner points based on this central one. So we need to use this function. We can say corners first generate these corner points. This general first generate these general corner points. We can say get corner. Yeah, I think I should say corners. Get corners with inputs. First one is size, right? The second one is the number of the corners, which is 6. The start angle we already defined. We already provided here, so we just say start angle, and we still need an angle step, which is 60, because this is a hexagon. When we have these points, when we have these corners, we need to move the corners from this point to each of the central points. So we need to do one thing. One more step is corners equals to corners dot map. We need to remap those values. We need to add each of the coordinates, each of the corner coordinates to these coordinates. Then we can say map pt equals to an empty list. No, it's not empty list. It's just creating a list of pt0 plus coordinate x and pt1 plus coordinate y. And then we have these corners. We can just push this corner to a new polygon list. So we need to define a new polygons list here. And then push these corners to the polygons list. Corners, I think that's no, I still need to return these polys. So I think this is all the contents of this grid function. Then we need to test this function. We need to say let polygons equals to grid. We can define the size as 60, but I prefer to declare a global value here. I can say const size equals to 60, and just this size, and maybe start angle could be 60 this time. We can modify this value to see which angle fits our design best. So I want to print console. I want to log these polylines here to check did I generate the correct polylines. It's not defined. 41. Start angle spelling issues. Oh, I should do no loop here. Or if I didn't do this, the sketch will refresh again and again. And yeah, you can see I have 144 polygons here, and I want to check the coordinate of each one. It might be right, but it's better to draw them out. And maybe if I do 70, that could be, because these two value matches, I think So let's visualize these polygons. We can say for this is the JavaScript. For let poly of polys, and for each polygon I need to draw vertex. I need to define vertex. So I can say pt with a chain function vertex pt 0 and pt 1. I should wrap this map function inside the begin shape and end shape. And shape, and I hope the shape is closed. The next thing I want to do is, I should remove the fill color and define the stroke color as white. Save it and run it again. Yeah, so we have these hexagons, but the angle is not right. They shouldn't be they shouldn't be intersected. They should attach to each other. So maybe I need to modify this angle value. Yeah, it should be 30. And now we have these base polygons. We can start think about the subdivision function for each polygon. And we need to create a new function. So I want to make write some comments like generating grade to make my by this way I will make my codes easier to read, or I always messed up with my own codes. So we need to define another function called subdivide. And we need vertices. We need the vertices of each polygon. Then we calculate, I think I can use this to explain. We need the vertices of each polygon, then we can calculate the center point. Then based on each corner point and the center point, I can create these sub-triangles. And yeah, this one is also the same. And from iteration 1 to iteration 2, the input polygon changes from this hexagon to this triangle. Then the next iteration is basically subdividing each of the triangle. If the iteration going on, they will subdivide each small sub-triangles. So this is the logic. So we need to first find the center point or the centroid of the polygon of this hexagon. So we need, So I think first thing I need to do is, I just mentioned I need to find the center point of the centroid of each polygon. I need first sum all the x coordinates and the y coordinates, then divide them with the number of corner points. So this is a way to calculate the average center of a given polygon. So I need to say sum x, sum y equals to 0 and 0. Sorry. And I should find the number of corners. So I can say vertices length equals to vertices dot length. And then I should loop over all the vertices. I can say for let v of vertices. Then sum x plus equals to v0, sum y plus equals to v with index of 1. Then when I get the sum of all the vertices, I can just divide them by the length. Then I will get the average center. So I can say central. I can define centroid equals to sum x divided by vertices length sum y divided by vertices length as well. Then we can get the centroid. The next thing is based on the centroid and the corner points, we will know how to organize the corner points and then to create a sub-polygon. Then then create a sub-triangle. Then I need to say I need to create a list, a new empty list to contain all of these triangles. I can say new polys equals to an empty list. Then I need to loop over all of the vertices. So I can say for let I equals to 0, when I is smaller than v length I plus plus, Then inside here, we can just create a new polygon. Poly equals to, we can start from vertex 0, centroid, vertex 1, and this one is vertex 1, 0, vertex 2. So it's basically vertices I, centroid, and vertices I plus 1, but be careful here because when we are looping to the as assuming we start from here 0, 1, 2, 3, 4, 5, when we are looping on these fifth points, the next points will be this one, will be the index 0 instead of index 6. If we provide the index 6, there will be an error, so we need to modulo this value by v length to avoid this unwanted error. And we have this new polygon. We just need to append this new polygon to the new polygons list. We can use push and new poly. Then at last we can just return this new poly. We can just return these newly generated polygons. We can say return new polys. I think we can try it out on our current pattern. I want to increase the size of pattern to reduce the computing burden of the computer and also make the result more clear. Where I can do it, I think polys equals I think I can do it here. I can say polygon grids. I can do this. I can say poly let new polys equals to polys dot reduce previous and current with a higher level function inside and also an empty list as the start point. Then inside here, I would like to say let poly equals to here subdivide. The poly equals to subdivide CURR, because current indicates each polygon inside this polys list, and then we should concact this newly generated polygon to the previous list. So we can say PEV equals to No, I think we just need to return this return prev.concat and put the newly generated polygon. Maybe, I hope this works. I can just try to visualize this. I can say new polys, refresh it. No, it doesn't work. Vertices is not defined. In line 42, TICES. Ah, stupid mistake. Oh yeah, it works. It actually works. So before this function, we have these hexagons, but with one iteration of subdivision, we get the polygon like this. Yeah. So the next thing is now we have this subdivision function. We need to create a recursive wrapper function to wrap this subdivision inside it. Then we can do the recursive subdivision based on the shape and the iteration we provided. And we should do it somewhere here. We need to create a new function. We need to name it as something like recursive subdivision. We need vertices as one of input and the iteration as another one. Now the first thing inside this function is we need to define a base case, which is one of the essential parts of the recursive function if you don't want to stuck in the Stack Overflow. So I can say if iteration equals 1, which is our base case, we just return the vertices. But yeah, I need to wrap it into a list because I don't want to mess the vertices with other new vertices I generated. Then I should say else. This is the recursive part of our recursive function. So I need a new polygons, new polys. Sorry, this is my naming custom. It might look very weird to you guys because the same variable appeared everywhere in this code. But yeah, I just hope I can recognize because these variables, I want to limit each of the variables strictly inside each function. So I don't want to mess up with the functions variable with the global variables. And yeah, in this condition, I want to make my code look super clean. So this is my way, but yeah, you can do it on your way. It's just some coding customs, so you don't need to follow me in this way. You can name the variable as you wish. Then the new polys should equal to the subdivided polygons. I need to move this function somewhere down here to make them organized. New polys equals to subdivide vertices. And after this step, we have some subdivided triangles. Then we need to loop over each triangle to do the further subdivisions. So we should loop over them. We can say for let poly of new polys. Then let's try to call this recursive subdivision function again. And in this time, the input becomes the poly and iteration -1. Then yes, we should store this value into another list. I want to call it let next polys equals to an empty list, and then append the result concat the result into this next polys. So it should be next polys equals to next polys dot concat. In this way, And finally, after all the loops, we just need to return. I mean, after all the recursions, we just need to return this next polys. Yeah. So here we want to do another test somewhere. Yeah, somewhere here in the subdivision test part. We should modify this function to curr. RE. Did I spell right? RECUR sub D. Yeah. Sub D. But now we still we start from 0. Test it. It seems correct. 1. Oh, it doesn't work. Vertices is not defined. Another spelling mistake. Oh my god. VERTICES. I'm always struggling with this kind of mistakes. Recursive sub D RECUR in line 55. RECUR sub D. Yeah. Refresh it. Next polys. Oh, next. It's not defined in line 58. Next. Next polys. Next polys. Oh yes, I shouldn't place it here because it's already outside the else. Yeah, now we have this. Then we can add one iteration to the subdivision. Where is it? It's here. Save it. Run. And keep adding to 3. Yeah, apparently this time it works. The next thing is I want to make it randomized. I don't want all of the polygons share the same iterations, because this makes the whole pattern looks very plain, looks very general. I want it looks varied. So inside here, I prefer to create a random value, then put the random value into this iteration. So I can say let iter equals to an integer number and random maybe 4. Then let's test it out. iter set. Yeah, so we basically have what we want now. The last thing is we want the pattern rotate a little bit to make some dynamic feeling. So what we want to change is only a start angle value somewhere here. Yeah, it's here. Now it's 30. We can modify it to 45. Yes, it's rotated. And we change back to 30. And I want to make this rotation kind of interactive, so maybe I want to create a slider. This is another feature of P5.js. We don't need the help of some other libraries. It's built in P5.js. So I want to do it here. I want to create an angle slider. Yeah. Let ngSilder. Just leave it blank, and inside this create canvas, inside this setup function, I can say number slider. Oh, sorry, it's angle slider. der equals to what's the syntax? Create slider. Hope it works. Create slider. And yeah, I think I still need to refer to the P5.js official reference because I'm kind of forget the syntax here. Slider, create slider. So let's see what's the input. Here, minimum value, maximum value, current value, and the step. So Minimum value could be 0, and the maximum value could be 60. And the current value is 30, while the step could be just 1. And now we should position it on our canvas. So I want it located somewhere below this canvas. So I can do angle slider dot position. And the first input should be the x value, x coordinate. I just set it as 10. The y coordinate could be height plus 10. And let me see, do we have this? Create slider, please. Yeah. E-A-T-E. Oh, sorry. S-L-I-D-E-R. Yeah. C-R-E-A-T-E. C-R-E-A-T-E-S-L-I-D-E-R. Slider. Oh, I think it's the problem here instead of the syntax itself. Yeah, we have our slider. Now we need to use the slider's value to control the rotation angle of each cells. So what we need to do is here I want to say, oh, it should be here. It should be this value. So I can say let angle equals to angle slider dot value. Then replace this value with the angle variable. And let's test it. Still not working. Let me see what I can do here. Yeah, let me first check, does the angle value successfully converted from slider to our environment? And I can just console dot. No, I think because I did the no loop here, if I remove this no loop, I believe, yeah, oh shit. Yeah, I need to stop this. It's harmful to my eyes. I need to just set the random seed to keep the whole pattern keep the whole pattern consistent. And I can say random seed. I set it as 100, and maybe this time when I remove this code, no more blinks. Yeah, I think we basically have all we want. The rest thing is just to customize colors and some other randomness things, like maybe you can just remove part of the triangles to make the whole pattern looks more dynamic, just like my image here. Yeah, just like my image here, I remove part of the triangle to create this kind of fragile pattern. So that's it for this video. Thank you so much for watching. See you. Bye bye.